Greetings and welcome to your experimental demonstration. The experiment that we will be conducting today is flow over a jump. The objective of this experiment is to measure or calculate the energy losses which occur when water or the flow is over a jump in an open channel flow. So now let's move on to the components that make up this experiment. Starting with this panel, which will indicate the different switches to control the apparatus. This is the pump, which will be turned on or off, the wave generator, and an emergency stop if the water overflows from the apparatus. This is the flume section. As you can see, the transparent open channel. Coming down, you will find the valve to control the inflow of water into the apparatus. This valve will decide the flow or the speed of the water that comes into the apparatus. This is the meter you will find here to indicate the discharge that is available in this apparatus. The pipes that are connected to the pump will take the water to the inflow tank, from where the water is coming into the apparatus. Now, in order to create a hydraulic jump in this apparatus, the weir has been taken to imitate a hydraulic jump. To measure the head of the flow or the level of the flow, the scale is used, which is movable from the upstream to the downstream. In the scale, the needle will be pointed on the top of the flow or the head of the flow, and the depth of the flow will be measured both in the upstream as well as in the downstream. This is the inflow tank from which the water is inflowing into the apparatus or the flume section, which is then flows and hits meets the weir, and an hydraulic jump is created, which then forms the downflow or the downstream, and the water is discharged through the outflow tank. So let's now move on to the experiment. So in order to start the experiment, the first step will be to turn on the pump to inflow the water into the system. Now that we started the pump, we can observe what was the discharge throughout this system. We will move on to the indicator. And you can observe in this, the discharge is maintained or fluctuates between 39 and 40. So by taking an average, we can consider 39.5 as an average discharge. So now let's move on to take the readings for finding the depth of water in the upstream section. For that, we will adjust the scale and move it to just be touching the top of the upstream flow. Now you can observe the needle is touching the upstream flow. So from the scale you can observe what is the depth of the upstream flow. As it says here, it's 39.4. Now that we have done that, you can move the scale towards the downstream. And we can measure what is the depth of the flow in the downstream. Continuing the same process, we will adjust the scale. To be just above the flow in the downstream. Now that's done, let's look at what is the depth of the downstream. As you can observe here, the depth of the downstream is 3 mm. So now we can move on to alter the discharge that or the speed of the water that comes into the section and take different readings for the upstream. Now let's move on to change the discharge coming into the apparatus. For that we will adjust this valve just a little bit and see the reading or the discharge coming into the apparatus through the indicator. As you can observe, the values are fluctuating around 49 and 50. So by taking an average, we can say that the discharge in the apparatus is at 50 meter cube per hour. So once again, let's move on to find the depth of the upstream. So now let's find out what is the depth of the upstream. For that, let's again adjust the scale so that it's just touching the okay. So now let's find what is the value, what is the depth of the upstream. The depth of the upstream is 44 mm, 40.4 mm. Now that's done, let's move the scale towards the downstream. And check the value in the downstream. That looks at the level of the downstream. Let's find out what is the depth of the flow of the downstream. As you can observe, the flow is at 3.3 mm. Now that's done, we can again change the discharge in the apparatus and move on to take different readings. Let's once again adjust the valve here and check the reading in the meter and find what is the discharge in the system. So as you can observe, the discharge is fluctuating between 59.8 and 60. So by taking an average, we can say that the discharge in this apparatus is 60 meter cube per hour. Let's once again move towards finding the depth of the flow in the upstream. Now that let's observe what is the reading. We find out it is 41.5 mm. Let's move the scale towards the downstream. And observe its readings again. Once again, adjust the scale so that it's just pointing at the top of the flow upstream. Now that's set, we can check what is the depth of the water in the downstream. As you will observe, it's 3.5 mm. These are the readings for the upstream and the downstream depth of the apparatus.